Hey students, we will move on to the next problem, problem number 4. See here, this problem is also very simple one. In a giga-Marsden experiment, calculate the distance of closest approach to the nucleus of an atom having atomic number 80 when the alpha particle of 8 mega electron volt energy impinges on it before it comes momentarily to rest and reverse its direction. How will distance of closest approach be affected when the kinetic energy of the particle is doubled? Now the problem is very simple. See here. So we have a nucleus over here, and you have seen in the giga-Marsden experiment, alpha particle comes close to the nucleus. Okay. The question what they have asked here is, you have an alpha particle, okay, energy of alpha particle is 8 mega electron volt, then it has got atomic number 80. Now the question is asked, when you double the energy, that means when E becomes 2E, what happens to R, or what happens to R naught? See, that is the question what is asked over here. So what we need to do, we have to calculate R naught first, right? Okay, we will calculate R naught. So we have given with the equation what we are given. So equation is known to us, E is equal to 1 by 4 pi epsilon naught 2 ZE square divided by R naught. You know this equation, you are familiar with this equation, right? Just check this equation. Now what we will substitute, we need R naught. From this equation, we will take E to this side and R naught this side to the left. Now what do you get? R naught is equal to 1 by 4 pi epsilon naught 2 ZE square divided by E. What is E? E is nothing but 8 mega electron volt. So you have to convert into joules. How to convert into joules? E is equal to 8 into 1.6 into 10 to the power minus 19 multiplied by 10 to the power 6. So electron volt to joule is converted by multiplying with the E value 1.6 into 10 to the power minus 19. Again it is mega electron volt, so mega is nothing but 10 to the power 6. Now you substitute all the values over here. R naught is equal to, what is this, 1 by 4 pi epsilon naught? It is nothing but 9 into 10 to the power 9. 2 multiplied by 80 atomic number, okay, of the nucleus. Then E value is known, 1.6 into 10 to the power minus 19, square of that divided by E value, 8 into 1.6 into 10 to the power minus 13. Why? See this, 10 to the power minus 19 and 10 to the power 6. Do the calculation, okay. So you can solve the powers separately. So do one thing, keep the powers. You have a normal calculator, right? So multiply by 9, 2 and 80. Then make the square of this. You can split the steps and write. Then keep the powers separate. See here, you will get how much? 10 to the power minus 38, right? Then what do you get? 10 to the power 9 over here. Then when it comes up, it will also become 10 to the power 13. So you have to deal with the powers. Powers will get added up. It is simply getting added up. Now what you are going to get? You will get the value 2.88 into 10 to the power minus 14. What is it? It is in terms of meter. Look at this value. See, this is the same thing what we told in the discussion of alpha particle scattering. Correct, right? Okay, this is the value of radius what you are going to get. So try to solve this problem. Okay. Now we will see when E becomes 2E. That is a question. So you are said there is an experiment happening and you get the values of R naught. Okay. When the energy of the alpha particle is doubled, what happens to the radius of closest approach? So E is equal to 2E. R naught dash can be written as R naught divided by 2. See, just check this equation. When E becomes 2E, what happens to R naught? See, it is just getting divided by 2, right? So R naught dash is nothing but R naught divided by 2. That is the idea. Now we will just substitute for R naught. Okay, 2.88 into 10 to the power minus 14 divided by 2 will give you 1.44 into 10 to the power minus 14. So this is the value. So try to solve the problem by your own. Okay, we will move on to the next problem. Calculate radius of the third Bohr orbit of hydrogen atom and energy of the electron in that orbit. So what you are asked to calculate? Radius of the third Bohr orbit of hydrogen atom and the energy of electron in that orbit. So we have the equation. We have seen this equation. See, n is equal to 3. Why? Third orbit. Then hydrogen atom, what is the value of Z? Atomic number 1. We have this equation. Do you remember this? We have calculated in the Bohr's postulate. Before Bohr postulate, we had solved some derivations where we found the Bohr radius, then the energy. Okay, from there we are taking the equation. So Rn is equal to epsilon naught into h square divided by pi m e square into n square divided by z. So substitute it over here. What do you get? It will be 9 divided by 1. So that 9 comes over here. Now what you are getting? R, you can write 3 or just write R, that is equal to 9 in epsilon naught h square divided by pi m e square. See, simple equation became like this. Now substitute the values. How to substitute the values? So you have to be careful. You are given with this epsilon naught value. You can have this value. Okay, epsilon naught value is a permittivity of free space. You can remember it. The value is nothing but 8.85 into 10 to the power minus 12. And h is a Planck's constant. This is not g. Okay, don't confuse with d. It is 9. It is 9. Okay. So 9 multiplied by epsilon naught, then square of h, 6.67 into 10 to the power minus 34, square of that, divided by pi, you know, right, 3.14. Then what is mass of electron? 9.1 into 10 to the power minus 31, again multiplied by e, square of e. Now see here, you can split the terms. That's what I told when you solve it with the normal calculator. Okay, what you need to do is take all the terms separately, then all the power separately. So this method you can use while when you solve without calculator. When you go for your CET and all, you are not supposed to use calculator, right? So at that time you can make use of this idea. So take the powers separate, take all the terms. Now multiply all the terms. Okay, get the value, keep it separate. See the power, okay, solve the power, denominator you solve, do the calculation of the normal terms, okay, then solve the powers separately. It is a work for you, you have to solve it by yourself and you should check whether you are getting the value 4.8 into 10 to the power minus 10. So what is it? 4.8 into 10 to the power minus 10, it is nothing but 4.8 angstrom. Okay. So that is the value of R. So we got the value of R. Now we have to get the value of E. So energy of electron in that orbit. So you have to substitute the values. For energy we have this equation. Again you remember this equation. Minus m e to the power 4 divided by 8 epsilon naught square h square, and in the bracket you have, otherwise you can have the bracket this side, z square divided by n square. Now what do you do? What is z? 1. We know that, right? Then what is n? It is 3. So again the same kind of substitution, minus is kept outside. Okay. 9.1 into 10 to the power minus 31 multiplied by 1.6 into 10 to the power minus 19 to the power 4. Okay. Here it is 1, so neglected, divided by 8 into epsilon naught Given the value permittivity of free space, you have to substitute it over here, then square of that. Again multiplied with the what this Planck's constant value, 6.67 into 10 to the power minus 34 square. Then n square, it is written over here, 9. Again the same method, take the terms separately, solve it, take the power separately, and you can check the answer from the board. Okay, do all the calculations and you are going to get the final answer. E is equal to minus 2.37 into 10 to the power minus 19. So you can see here, if you need, you can round off this number to two significant figures. You have studied in your first year significant figures, so don't need to do the calculation like this. See, you can simplify the terms on. You can write, if you want, you can write just to 78.3 also, no problem, because the answer will be nearly this much only. This uncertain values might change, but this value will be the same. Okay, so try to solve all the problems from the textbook also. Okay, then if you need some more problems, you will solve it when you come to the college. Okay.